is that the lag is, or like in terms of the text, you can see it pretty well. So that's the good news, I suppose. Okay, so cool. So let's look at the first problem. 961B. I'm just gonna read the problem to review it to everyone. So your friend Misha and you attend a calculus lecture. The lecture lasts n minutes. Lecturer tells AI theorems during the ith minute. Misha is really interested in calculus, though it is hard for her to stay awake for all time of the lecture. You are given array T of Misha's behavior. If Mishka is asleep during the ith minute of the lecture, then Ti will be 0, otherwise it'll be 1. When he's awake, he writes down all the theorems he's being told, AI during the ith minute, otherwise he writes down nothing. You know some secret technique to keep him awake for k minutes straight. However, you can only use it once. You can start using it at the beginning of any minute between 1 and n minus k plus 1. If you use it on some minute I, then he will be awake during minute j from j equals I to I plus k minus 1, and write down all the theorems the lecturer tells. Your task is to calculate the minimum number of theorems he will be able to write down if you use your technique only once to wake him up. So the first number is the duration of the lectures and the number of minutes that our potion can keep him awake. The second number is the number of theorems that is being told each minute. And the third number is whether he is awake or asleep during that minute. Okay, so I'm just gonna talk through it. Just check this one more time before I start. Okay. Yeah, it's too late to lower the resolution now. Last week I got comments to increase the resolution, so I increased it, but now it's too late. Okay, what do you mean the video is messed up? Okay, so I'm just gonna talk through how I would solve the problem if I was solving it from scratch. So the first thing I observe is that if he is already awake, like if Ti equals 1, then he will get all the theorems during that moment, right? So, for example, in the sample input, he automatically gets this 1 here, the 3 here, and the 2 here. So I'm going to use sketchpad.io for this. Okay, resolution's fine, I can see it now. Cool. Okay, so, right, the sample input looks something like this. 1, 3, 5, 2, 5, 4, right? And then T is 1, 1, 0, 1, 0, 0. Okay, so if it is a 1, then we automatically take these, right? The potion doesn't help at all. We get these whether or not we take the potion. So we can just add these to our answer. We can say our answer equals the sum of everything that's currently a 1, which in this case is 6. And then we can turn those numbers into zeros. And the reason we put them as zeros is because the potion doesn't help them at all, right? We want to find the range which the potion helps the most for. And so if the potion doesn't help them at all, we just change them to zeros. This is because, well, we already took them. They're useless now and they give us 0 more. Okay, then as you're thinking through the problem, the next thing you're thinking is, okay, the potion can keep you awake for any consecutive k minutes. So I'm just going to write down I on the bottom here. I is 0, 1, 2, 3, 4, 5. And the reason I'm doing this is because it says that the range goes from I to I plus k minus 1. So let's say I equals 0 and k equals 3, right? In the sample input, k equals 3. Just going to write that over here. Okay, so 0 plus 3 minus 1 is 2. So this is the range. So if k equals 3, we take 3 values. Okay, so now I'm just thinking to myself, how can I get the max range of 3? So I could loop through all of them, but that would be too slow. So another option is I could use something called prefix sums. And here's how prefix sums work. For prefix sums, I simply, okay, let me just add the prefix sums up here. I simply say prefix of I equals the sum of all the numbers from this is loader, right? I apologize. From 0 to I. Okay, so by the prefix 0 would equal to 0 because the sum of all the numbers from 0 to 0 is 0. Then prefix 1 also equals 0 because the sum of all the numbers from here, and again, we're only adding the numbers on the top, that also equals 0. And the next one is 5 because the sum of all the numbers here is 5. And then we get 5 again because the sum of all the numbers here, oh, that was bad, but you get the idea, equals 5. And then the next number is 10 because the sum of all the numbers here equals 10. And the last one is 14 because the sum of all the numbers from 0 to I is 14. Okay, I'm going to check questions. Sure, I'll discuss the two-pointer solution also. Okay, so then let's think about, okay, how do we get prefix I? So I'm going to say that prefix I, so the reason that I'm writing and not typing, and I saw a comment about that, is because it's easier to draw stuff. So for example, if I want to find out prefix of 14 here, right? Then I'm trying to get this entire range here. Okay, this entire range here equals this entire range here plus the 4, right? So the 4 equals input of I, and then, oh shoot, this entire range here equals prefix of I minus 1. Okay, actually I'm not going to discuss the two-pointer solution because the topic here is DP, but there is a two-pointer solution, and you can think about that yourself, and you can talk about it with others in the V Planet Discord channel if you're interested. Alright, cool. So now we set our prefix I array so that prefix I is the sum of all the numbers from 0 to I. Okay, are there any questions about this? And I'm gonna keep on moving, but like I will check the questions in about a minute-ish to give count for 30 seconds lag and 30 seconds for you to actually ask questions. So I'm just gonna move on, but if you have any questions, feel free to ask them still. Okay, so now we have prefix I, that's great. Now, the next thing is we have a prefix array. So first of all, let's write down our original array, right? This is our original array because we removed everything that's a 1. So I'm just going to type this. Okay, and then our prefix array is the sum, which is 0, 0, 5, 5, 10, 14. Okay, so now let's just say, now we need to find the sum of all ranges of 3. We need to find the sum of, the sum of this range, the sum of this range, the sum of this range, the sum of this range. We find all the sum of ranges of length k. So let's just say that, okay, so a prefix array looks something like 0, 0, 5, 5, 10, oops, 14. Okay. Now, if we want to find the sum of these 3 elements here, we need to take, you want to find the sum of the range of the input array of these values, right? So, lucky for us, 5 gives us the sum of this range here. Okay, I'll check the questions right now. Can this be done with sliding window? Yes, that is a 2-pointer solution. I'm not listening to twice on the stream. Okay. Send me a link for music and I'll put it on. The video will probably be available after you go to sleep. Yeah, I'm just probably gonna keep them up. Have fun sleeping, I guess. Okay, so we originally wanted to find the range from here to here, right? So we got this big range there, and then we just need to subtract this range here. So I'm saying that the range from A to B, or the sum of the range from A to B, equals prefix of B minus prefix of A minus 1. Oh, copyright's a good point. Okay, no music. No music. I'll show the comment, but no music. Okay, sum of the range from A to B is prefix B minus prefix A minus 1. And let's just do another example. If you're trying to find the range from 10 to 5, then we have prefix B, which is this whole thing right here, minus prefix A, which is this whole thing here. So if we take this big range here, and we subtract out this little range here, and then we end up with this section here, which is what we want. Okay, this is the whole entire algorithm pretty much. So, a couple of things. First of all, do I need to code this? And second of all, are there any questions? I'm gonna check the lag, and I'll give you guys a minute-ish to answer. Okay, I'll take no comment as no code. Okay, no code is good. Alright, cool. I think I wrote pretty much a lot of the code there. These are all the bits that you need to know to write this. I'm not gonna discuss about the range again, but you can always like go back and rewatch the part. Okay, so let's move on to the next problem. Okay, now let's probably, you can look at my submissions here, right? It's kind of hard to AC, just because there's like a lot of tricky edge cases. But the uh idea is pretty nice. It's a similar idea to this one in terms of prefix sums. So I'm just gonna read it real quick. In a distant future on Earth, days last for n hours, so there's n time zones. Local time zones are different by 1 hour. For describing local time zones, we use the numbers 1 through n. There is no 0 hours. Instead, it's n hours. Basically like a mod thing. When local when local time is in the 1s time zone is 1 hour, the local time in the I time zone is I hours. Some online programming contest wants to conduct a contest that lasts for an hour in such a way that its beginning coincides with some hour in all time zones. The platform knows that there are AI people from the I time zone who want to participate in the contest. Each person will participate if and only if the contest starts no more than S hours, 0 minutes local time, and will not end later than F hours, 0 minutes local times. F and F are equal for all time zones. If a contest starts at F hours, 0 minutes local time, the person will not participate. So basically, it's not inclusive. Help platforms select such an hour such that the number of people who participate in the contest will be maximum. Alright, cool. So, um, the idea here is pretty straightforward. So let's just look at the first sample input here. Uh, so first of all, let's just say that, okay, let's look at this thing here, right? S equals 1, F equals 3. The first thing you can do when you get a problem is to understand it, is to understand the sample input. So let's try to do that, right? S equals 1 and F equals 3. So, oops. So this means that, let's see, it's optimal to start the competition at 3 hours in the first time zone. So it'll be 2 hours, 3 hours in the first time zone. So it'll be 1 hour in the second time zone and 2 hours in the third time zone. So something like this. And then in the second time zone, or in the second sample input, okay, let's just first look at this first sample input, right? So let's just say that you set it to 1 hour in the first time zone. Then it'll be 2 hours in the second time zone, and it'll be 3 hours in the third time zone. And this also works. And they put that note just to confuse you a bit. But the idea is that with 1, 2, 3, or 1 hour in the first, 2 hours in the second, 3 hours in the third, then all of it fits between S and F. But the only issue is that for 3, it doesn't actually work, right? So it has to start with 1 and 2. So then the answer is simply 1 and 2, and the input is 1. I'll put input, and this is time zone equals 1, 2, 3. Okay, so since the time zone 1 and 2 are what we add the answer for, the answer is 3. Or sorry, the number of people who can get it is 3. The answer would then be 1, because you're supposed to output beginning time in the first contest. However, what they're saying is we can do better, right? So if this 3 loops around and it comes here, then 1 and 2 can get 5 people, because when the time zone is at 1 and 2, oh sorry, I moved the wrong one. Sorry, I'm confusing myself a bit. Okay, we remove the time zone over. We don't move the input. Okay, so when the time zone is at 1 and 2, we get 2 and 3 people, for a total of 5 people, and this is the maximum. And the output is 3 because that's the time of the first one. Okay, I'm just gonna check the questions before I start talking about the solution. Please code the first question. If you're, you could just ask other people in this chat about the code for the first question. Most of the code's there anyways. And yeah, you can look at my code for that problem that's already submitted a while ago. Okay. So time zone can be alright, so the thing here is, so then the option for time zone is, then we can take 2 here and we put 2 at the beginning. And we can repeat. Okay, so basically what we're doing is we're doing a wraparound. And when we do a wraparound, you can always just double the array. So you do a wraparound and you double the array, and then you can look at all ranges of 3. So this is one possible, this is one possible, this is one possible, and this of course is one possible. We don't need to copy the last one because we already looked at that. But let's look, what does this here represent, right? So any range of n items that you take with n time zones, which represents a different cycle. This represents that time zone 1 is in time zone 1, 2 is in 2, 3 is in 3. This represents that 1 is in time zone 1. Oh, sorry. Okay, you don't need to double the time zone array. Okay, this represents, it goes diagonally. So 1 is in time zone 3, 2 is in time zone 1, and 3 is in time zone 2, right? And this represents that 1 is in time zone 2, 2 is in time zone 3, and 3 is in time zone 1. Alright, cool. So the idea is that since we're trying to find the continuous thing from S to F, right? The range we have equals F minus S. And in this case, is 3 minus 1 equals 2, which means that we can take the sum of any two adjacent numbers. It can be 1, 2, it can be 2, 3, it can be 3, 1, and it can be 1, 2. And this is because when we pick this range here, we match up the first two with time zones, right? With time zone 1 and 2. And we pick this range here, we can match up the first two, which is 2 and 3. We pick this range here, we can match up the first two. Sorry, this range here, we can match up the first two, which is 3 and 1. And so our range includes 2 people. So we double our input array, and then we loop through it, and we take the maximum of every range of 2 people to get the maximum answer. And we can again use prefix sums to do that. Alright, and then the question is, so then from taking the maximums, we can find out the maximum number of people who are able to participate. The question is, how do we find out the output, which is the time zone of the first contest, right? And for that, what we do is, okay, so let me put the index of the contest here. In this problem statement, the index happens to equal the value, so I'm just going to put 0, 1, 2, so that slightly. Okay, so if we take this range, so if we take these two right here, then that represents this range here, which means that that 0 is at input 1, right? Now if we take this range here, so if we take these two values, and that represents this range here, which means that 0 is at, the time zone of 0 is 3, because it's the third value. 1, 2, so then we basically just shift this over, right? So it's at the third value. And we don't need to actually have this array, because it's just 1, 2, 3, or in order. But yeah, so I'm taking these two items here, then we look, 0 is at 3, and then we shift this over one more. We take these two items here, and 0 is at 2, and we shift this over one more. We take these two items here, and we look, 0 is at 1. And that's how we figure out the time zone. Okay, are there any questions, and do I need to code this? Okay, nice that you guys were able to check this out. Okay, coding wouldn't be bad. I assume that's a positive. So, alright, I'm just gonna ignore these two. I need like a straightforward code or no code answer. Let's see. Don't code is 1. Code is 1. And these two cancel. These also cancel. Don't code. Code. These two cancel. Oh wait, these two are the same person. These two kind of cancel. Okay, since we have a little bit of time, I'll just explain my code. I didn't know I'd be explaining it, so it has some number of defines in it. So I'll just rewrite it without the defines, so you can see it basically. Okay, I did this without an input array. I'll just add it back, and then I'll explain the code. Okay, just make sure this compiles and is correct. I'll try a long walk. I don't remember if this was an issue or not, but I don't want to come into any issues because of not using long walk. Okay, so samples are right, so I'm just going to assume this is right and explain this code. Okay, so the first thing I do is I read in the input array, which is how many people are competing, and I also double the size of the input array. So I double it because we loop around, right? And then I say n times equals 2. This is because I doubled the size, so I'm doubling n. Okay, cool. Then I read an SNF, which is the start and ending time zones. And the len equals f minus s, finish minus start, because that is how many we can take at one time. So the next thing I do here is I create the prefix sum array. So prefix 0 just equals input 0, because the sum of the numbers from 0 up to 0 is simply input 0. And then for every future prefix, I discussed this in the previous problem, prefix of I equals input of I plus prefix of I minus 1. That's the sum of numbers from 0 to I. Okay, this is the tricky part here. This is the part where I find the answer and I need to store the time zone. So I initialize sum and out here. Basically, you put them into global variable they start out as 0. I could just put them here, I suppose. Sum is the maximum number of people I can get, and out is the answer. Okay, so I loop from I equals 1 to I minus len plus 1, and this is the starting number. Now, so if you look back here, you might remember that when we looked through this, we did 0, 1, 2 twice, right? So I just simply skipped the first one, and it started here. And the reason is that there's a lot of base cases, because if you're trying to do prefix of b minus prefix of a minus 1 and a equals 0, there's a base case there. So I just avoided it by starting here and just looking at this range, and that range. Alright, so long x equals s minus I plus n mod n over 2. This is a bit complicated. S is the start time. S minus I. This is the current index that you're at. So basically, I take the start time and I subtract the current index, which is sort of like the current time zone. And then this is just to make sure that you don't mod. This is to make sure that you don't wrap around. So I can be up to and I probably add an extra n, but so you add 2n to make sure that you're not a negative number, and then you take modulo because you want to reduce yourself to the beginning of the array. Okay, and then if equals 0, it equals n over 2. So the number is n over 2 simply because we multiplied n by 2. So this whole thing is n. N over 2 is only one section. We want to make sure that we start in the first half, because let's just say that we start here or in the second half. Forget this one. Let's say we start anywhere else in the second half. We don't want to do that because there's an equivalent starting point in the first half. And if we start, like, say at the 2 here, we might try to overflow here, and there's nothing there. So we start in here because this is why we double the array. Now the exception is a 0 here. Remember how I skipped this here by starting at 1? So I do allow to start here by saying that if x equals 0, x equals n over 2. So basically, if we were to start here, we start here instead. So our starting range can be anything from 1 to n over 2, which is the original n. This might be a bit tricky, but x is where we start. Okay, if prefix I plus len minus 1 minus prefix I plus 1. So this is prefix b minus prefix a minus 1. If it's greater than the current sum, then we got ourselves an answer. Alright, in the problem it says, if there are multiple answers, output the smallest amongst all of them. Multiple answers being the time of the beginning of the content. So if it's equal, so if it's smaller, if it's a better answer, we're done. That's right, not we're done, but this is we're definitely taking this. However, if they're equal, then we have to check if our current time zone is better than the best time zone so far. Because then we also need to update it, because this is to output the smallest. So if the amount of people who participate is equal but the time zone is smaller, this is also an answer. So then we update our sum and we update our time zone. And then we just print the time zone at the end. Okay, any questions? I'll just wait a couple minutes for questions. Alright, no questions? That's great. It seems like the lag is increasing by a couple seconds every 30 minutes, but I suppose that's fine. Okay, let's make a new one of these. Okay, this next problem is barn painting. And it was recommended by Michael, and it's his DP on trees problem. So let's just read the problem real quick. Farmer John has a large farm with N barns, some of which are already painted and some not yet painted. Farmer John wants to paint these remaining barns so that all the barns are painted, but he only has 3 color paints available. Moreover, his pride cow Bessie becomes so confused if 2 barns are that are directly reachable from one another are the same color. Okay, I'm just gonna put you on timeout for a little bit because you're just adding stuff. And then if you wanna like not put random comments like spam comments, then that's fine. What is X? X is the index that you're starting at. Yeah, I'm gonna try to solve all the problems, and I'm trying to spend more time in seeing a third and fourth problem. We have about 50 minutes for them, so that's great. We spent 40 minutes on the first two, 15 minutes on the last two. A little more time. What do you mean by CL? Okay. It is guaranteed that the connections between N barns do not find. Oh yeah. However, Bessie becomes confused if 2 barns that are directly reachable from one another are the same color. So he wants to make sure that this situation does not happen. It is guaranteed that the connections between the N barns do not form any cycles. That is, between any 2 barns, there is at most one sequence of connections reading from one to another. In how many ways can Farmer John paint the remaining yet uncolored barns? Okay, so you're given the number of barns and the number of barns that have already been painted, and you are given the structure of the tree. And then you are given whichever barns are painted with whichever color. So this is a simple input. Let me draw this. We're just gonna end the question thing for that. Okay, cool. So you have node 1 is connected to node 2 and 3 and 4. Alright, cool. I'm sorry about this big 3 thing. There we go. Actually, I'll just redraw that. Okay, so the only thing we know, or in terms of color, is that the color of node 4 is 3. So I'll put a little 3 on the corner. Then we want to figure out how many ways are there to color the remaining barns in different colors. So, and you have to print this modulo 10 to the 9 plus 7. Which suggests that you cannot loop through all possible barn colorings. Okay, so given that you know it's a DP on trees problem, you need to find some DP state. DP almost always has DP node. DP node color equals, and DP on trees problems almost always have to do something with the subtree, right? So DP node color equals number of ways, and the problem statement is the number of valid ways to repaint the remaining barns. Actually, I think I'll just put this as a diagram and then just type everything here. so that it's faster. So to paint the subtree, the barn, given that the current node has hash map has the current color. So for example, DP1 will be the number of valid ways to paint the barn, such that the subtree of 1 has color equal to 1. So if we paint this one 1, how many ways are there to paint the barn? Is what we're asking, essentially. And we came up with this. Here's how we came up with this. So we knew it was a DP problem, right? So DP node. Since there's only 3 possible colors, we just might as well add that. And then the answer is asking us to output the number of valid ways to paint the remaining barn. Okay, so this equals the number of valid ways to paint the subtree, because DP on nodes is always subtree. Alright, if you have questions, put them now and then I'll check them in about a minute to account for lag and time to attempt to write your questions. Just gonna check the lag again, see how bad it is. Okay, so the next question is, given DP node color, so okay, for DP, here, I'll move this here. Okay, to define a DP node color, we need to know the number of valid ways to paint the subtree, given that the node has the current color, right? So let's just try to find DP node color, given that anything in the subtree is solved. Okay, it seems like the lag is about the same. So to solve this, we will recursively solve. So this means that solve all the subtrees, or solve all the children before solving the current node. Okay, now let's look at base cases, right? Let's just say the base case that we have is, since we're trying to recursively solve and solve all the children before solving the current node, the base case is if the current node is a leaf. Oh yeah, it doesn't matter where we root. Just root the tree anywhere. I like to root it at 1, just because it's easier. Well, it doesn't really matter. Okay. So the base case is the current node is a leaf. If the current node is a leaf, then you have 2 options. Option 1, not 2 options, the two cases. Option 1, the color of the current leaf is already given to us, right? And in this case, if color equals color of current leaf, I mean, like, that means that this is possible, then DP node color equals 1. Else, this is not possible, and DP node color equals 0, because this is not a possible option to have. Okay, the second case is that the color of the node is not given. It means that this current thing could be anything it wants, so we just say that DP node color equals 1. Because if we know the current color and the current node, there's one way to do it. We just set the a node to the color, and we're good. Alright, look at questions. Yes, I always try to deduce the state first and then the transitions. Ways to paint the subtree. What subtree? Ways to paint the subtree is all the nodes below the current nodes. You could probably do DP on trees iteratively. Yes, you probably could. You could actually. To do this, you would need to make like a DFS ordering. You would need to recursively come up with the DFS order and then do it iteratively. I don't know what you mean by this specifically. Can you please clarify what's the condition that we need to make sure does not happen? If you could clarify what you mean by that, I could probably answer it again. Now, on the same note, if you have any questions about what I put first, the base case, and to solve, and any of the things I wrote so far, feel free to ask, and I will check back in like a minute or so. Also, stop spamming. Okay, cool. So this was the base case. And now we need to solve it for another node. Okay, so to solve the current node, what we need to do is, so we already assume that we know all the leaf nodes, right? So note that all the leaf nodes cannot have the same color as the current node because they're all connected by edges. So again, here we have two cases. The first case is the current node, the color of the current node of the node is given to us and it is not color. In this case, we say that dp node color equals 0 because this is not possible. There's 0 ways to do this because the current node cannot have this color. Okay, and then we think, okay, so let me check the questions. Oh yeah, okay, so we need to make sure that any two nodes that are connected by an edge, connected by a singular edge, do not have the same color. So if you have an edge, the two nodes on opposite sides of that edge are not the same color. I got your question now, and I hope I answered it. If not, please ask again. Alright, cool. Okay, so the other option is either the color of the current node is given to us and it is the same as the current color, or the color of the current node is not given to us. Either way, basically what this means is this is a valid option. Okay, so in this case, what we do is, so we loop through all the leaves, right? And so for all the leaves, we need to know, okay, so let's just look at the sample input here. So if we decide, so let's just say, let's look at the DP. If we decide to make this a 1, there's one way to do that. If we decide to make this a 2, there's one way to do that. If we decide to make this a 3, there's one way to do that. And this is based on the base case I have for leaves here. Okay, same thing for 3. If we decide to make this a 1, there's one way. 2, there's one way, and 3, there's one way. Okay, for here, if we decide to make this a 1, there's 0 ways, because the 4 is already colored to 3. Decide to make this a 2, again 0 ways, because it's already colored to 3. And if I have to make it a 3, there's one way, because it's colored to 3. Okay, now we're trying to figure out how many ways are there to make 1 into the color 1. So we have to basically multiply the options of all the children. So this means that if this is a 1, right, then 4 can be a 2 or a 3 for a total of 1 option. 2 can also be a 2 or a 3 for a total of 2 options. And 3 can be a 2 or a 3 for a total of 2 options. So we multiply all of them together, 1 times 2 times 2, to get 4. There's 4 ways to do this. You repeat the process for 2, and I promise you'll get the same thing, 4. If you repeat the process for 3, however, and then then this becomes 0 and 1. So this becomes 0. And this is 2, and this will also be 2, just for the new ranges. This is 2, and this is also 2. So then you do 0 times 2 times 2 equals 0. And this is correct, because you cannot make 1 a 3, because otherwise it'll clash with this, which is already a 3. Okay, so just to write the formula really quick. I'll put all the other codes. I mean, just another color. And this is for all trial notes. This is the formula. Okay, couple questions. Are there any questions, first of all? And second of all, do I need to code this? Could I explain the base cases again? Alright, sure. So the base cases are here are the base cases right here. And basically what the base cases are is if the current node is a leaf, then either the color of the current leaf is already given to us. So that was in this case here, we were already given that 4 is definitely colored to color 3. So we just made so then there's one. Okay, so since 4 has color 3, the number of ways for 4 to be color 1 is 0. And the number of ways for 4 to be color 2 is 0, but the number of ways for 4 to be color 3 is 1. Simply, for all the other nodes, we don't know their color. So for all the other leaves, the number of ways to set their color is 1. Oh yeah, and then the answer is the sum of all the dp of the root. I'll just add that in. Okay, it looks like I'm gonna code it. I'll just put the formula dp root. Okay. Alright, looks like I'll code this. Should I talk through it while I'm coding it to make it slower, or should I just code it? Let's see. Okay, so we take the sum of the end because it's possible for the root to be 1, 2, or 3, not all of it. there's too many characters, so I can't send the whole thing. Answer questions while I'm putting. Alright, sounds good. Okay, this looks like... Okay, I'm just gonna read the input, and then, this is an adjacency array. Let's see. The maximum n can be 10 to the power 5. Product is not correct, because otherwise, it would be 4 times 4 is 16, but the answer is 8. Could I show another example? Okay, cool. Send me an example, and I'll show it. Wait, I just told you why product doesn't work on this example. Let's see. What is this question that is valid? Oh, okay. I don't understand where the optimal structure of this DP problem. I mean, could you take an example where DP avoid us to pre-compute the same answer twice? I don't understand what you mean. Okay. What do you mean avoid us to pre-compute the same answer twice? The optimal substructure of this is that we only solve each subtree once. So we only look at each node one time. So it has to be correct on all the examples for it to work. And honestly, you're just spamming. Yeah, so if you could elaborate on your question, this one, I will be happy to answer it. Just elaborate a little more, please. Okay, this is because I'm using zero-based indexing. This is my DP array. I'm also going to have a visited array, simply because I want to make sure I don't look at any node twice, and the edges are both ways. Okay, we're going to go from root, which is at 0. Start at 0. This is basically called DFS. Because what it's doing is basically just a DFS. If it's already visited, then we're done. Don't even bother looking at it. Otherwise, mark it as visited. And then for everything underneath you. Okay, let's just have an int. Oh yeah, we also need color. Actually, we can just send all the colors at the same time. Actually, yeah, let's just do color. Okay, so we'll put in the color too. Sure. Does it just... If we could use plain recursion without DP, it would be called... Yes, you would. Okay, so that's a. Okay, yeah. That's it. Okay, I get what you're saying. So yes, you would. So let's just make this a new example here. Okay, so I'll color this 1, and then I'll color this, say, 2, and then I color this 1, and I color this 1, and I color this 2. Right? So I got, okay, so let's just say, right? So basically for 2, I put 1 here and 1 here. Okay, and then when I mark this as 3, I again put 1 here and 1 here. Does that answer your question somehow? I hope so. Let me know if you still have a question about that. Okay. So your equation and your color. Oh yeah, and the visited also needs to include color. Okay, the next thing we need to know is you also need to read in the input for if there's already painted. So originally, I guess we'll just assume that nothing is painted. Okay, yeah, painted starts out as 0. So then we just need to read uh, the k values of the barns that are already painted. And a minus 1 because we're using 0-based indexing. Alright, cool. So if painted at is not equal to 0 and painted at is not equal to color, meaning if it's supposed to be another color, then dp at color equals 0, and we just return. There's no ways to do this. I guess it's already initialized to 0, but I'll put this here anyways. Okay. The next thing we need to do is we loop through. Otherwise, we say that there is one way to do this, and we'll just multiply on more ways. We'll add on to that, we'll add on more ways. For int I in adjacency at, this is for all our adjacencies. We say if it's not yet, okay, so we'll also send in the parent. I'll put -1 as the parent for starting initially, but this basically just ensures that we don't go backwards. If I is not equal to your parent, if I is not your parent, then we multiply with however many options we get from the current child, because then we are at a child. And the number of options we get from the current child is dpi. So we need to find the other 2 colors. Okay. If color equals 1, then C1 equals 2 and C2 equals 3. If color equals 2, then C1 equals 1 and C2 equals 3. And if color equals 3, then C1 equals 1 and C2 equals 3. Okay, so we need the other 2 colors. Oh yeah, we first need to make sure that these values are correct. So we need to DFS into them. Oh yeah, I answered someone's question and I asked if they have follow-ups. Let me see. Yes, you can do the answer recursively, and I said you could do a DFS ordering, which is basically a topological help sort. But the thing is, so you can. This is perfectly thing. You would just do DFS, and you would do it iteratively instead of recursively. So this is yes. The answer is yes. You can do that. It would just be iteratively instead of recursively. Okay. DFS I C1 and DFS I C2. Cool. So you search into all of those, and then at the end we just print dp01 plus dp02 plus dp03. And okay, let's try this out. Oh. Oh yeah, so your parent is your current node because you're going to your child from your current node. Okay, oh yeah, I need to take it modulo 10 to the 9 plus 7, which means that I need to use long. So one thing you can do is you can define int long, and then you just delete this thing here. Cool, so now all the ints are longs, and then we could also have constant int modulo equals 10 to the 9, 1, 2, 3, plus 7. Okay, so dp at equals dp at color mod equals mod, and we just print it out mod. Same answer. Alright, cool. Let me just try submitting this. Oh yeah, do you have a follow-up question? Okay, no discussing USICO problems. I've said this before. Like, the USICO contest is still running, just don't discuss them. Yes, you can have this code via pastebin. Okay, I'm just gonna submit this real quick, and then hopefully it's correct. Right. Cool. Okay, this works. This actually is the indices, and this is the indices. So yeah, I will add this on pastebin later. We're running out of time, and I want to go with the last problem. So for int I and vector. Oh yeah, you're right. This does go to a number, not the indices. Good point. Okay, that answers that question. Cool. You can ask your questions, please do. I'm just gonna move on to the next one because I don't want to waste that much time. Okay, the challenge problem. So this is a pretty straightforward problem statement. You're given an array of n numbers. You want to choose a subset of exactly k numbers so that it has the maximum number of zeros at the end. Probably difficulty of, I don't know, maybe div2D, div2C. Why call DFS thrice? Because we have to figure it out if the color is 1, 2, or 3. Because the color could be any of the 3 colors. we don't know what the root node is, or what the root node number 0 is colored. Okay, does that answer your question? If not, please ask again. Okay, this is not true. I muted you because you were spamming. Maybe we should just ban him. If you keep like spamming like this, I'm just gonna ban you, honestly. Alright. Last problem. The maximum roundness. So thing to keep in mind is the number of zeros at the end of the number is the number of tens in the product. This is the same as, right? So like, yeah, this equals the number of fives in the product, or this equals the min of the number of fives in the product and the number of twos in the product. Okay, let's make sure there's no questions about that problem. So you could do with one DFS call solve all the values of color that are possible. I just chose not to do it that way, but is it Vicky V? That is also a possible solution. There's multiple ways to solve this. Exactly, this problem can be approached with a kind of knapsack problem. So we're trying to find the number of fives in the product and the number of twos in the product. So, okay, the numbers can go up to 10 to the power of 18, right? So to find the max number of 5, or the max number of 2's, we just take log base 2 of 10 to the power of 18. 1, 2, 3, which is 60. And then the number of 5's is a lot less than 60. So this means that we can do dp index number of 2's and number of 5's. Okay, the index can go up to like 0 to n. Sure, says no. Okay, the number of 2's can be n times 60. And the number of 5's, let's find a log base 5 calculator. Nope. Okay, log base 5 of 1, 2, 3 is 26. Let's just call it 26. So this is n times 26. Okay, given that n equals 200, this is a fairly decent sized array, and we can do this as our input. So dp index number of 2's, number of 5's. We also care about how many numbers we've chosen. And this can go up to k. And this is a boolean, and it equals true or false. Is this possible to make? Okay. However, when we add that in, that becomes a little more, then the array gets a little bigger, right? And so what we can do is we can change it to this thing here. So we can remove and Okay, we can remove, so we look at all the dimensions, right? K, which is pretty much n. I'm just going to change this to n, because k could be up to n. This is the biggest dimension in the array. We can cut this dimension out to say this equals the maximum number of 2's. And this saves all the information we wanted to save. We decrease the array by size 60n, and we have this now. And this is now the runtime will work, because earlier the runtime would even be too slow. Now the runtime's good. The memory is still a little bad, but we'll discuss that a little later. The number of 5's in the product, like the number of factors. Number of, so like, for example, if you have the number 25, the number of 5's equals 2. And then if you have the number, say, like, say you have the number 10, the number of 5's equals 1, because it's basically the number of factors. The number of times 5 is a factor. And the same thing for the number of 2's. I hope that answers your question. Okay, cool. So now basically what we need to do is what we need to do is we need to be able to calculate this DP array. And I'm just showing you my code because I don't want to rewrite it basically, because I don't think we have time. So the first thing we do here, and I'll explaining it as we're talking about the solution, is we pre-compute the number of 2's and 5's in every array, in every number in the array, sorry. So for the sample input, we're given 5, 4, 20, right? And then we store the number of 2's. There's 0 2's here, 2 2's here, and 2 2's here. And the number of 5's, there's 1 5 here, 0 5's here, and 1 5 here. And we pre-compute this, and we won't have to compute this at every step of our DP array. And again, this is the challenge problem, so it's slightly hard. It's a bit harder. Okay. Then what we do is we need our transitions, right? So let's just say that what I did was here I did a push, not a pull. So basically, let's just say we know dp I j k, right? From this, or actually this equals, I'll use a different solution. Okay, so j is how many numbers we took, right? So so there's two options. Either we take a, or we take I, or we don't take I. So if we take I, then, or actually if we don't take I, simple. I'll do that first. If we don't take I, then the same as dp I minus 1 jk. Because nothing changed. Nothing at all changed. Okay, if we do take I, then that's the same as dp I minus 1 j minus 1 k minus the number of 5's of I equals max of what it already is. I don't want to write or else. Copy this. And or what it max of that value. Sorry. It equals max of dp I j k, or this value plus the number of 2's of I. The max 2's that you can get is whatever you currently have, or from the previous number, you add in the number of 2's that you currently have. So if you take the current value, the number of 5's is k minus the number of 5's that you're adding, and you're also adding the number of 2's. Okay. Are there any questions so far? Cool. I'm glad that's clarified. So the problems are in the description. Alright, I guess I'll just look at the questions a bit later. I want to talk about. Or, I'll just type it so it's faster. Okay. Basically, do you know sliding window? Do you not know sliding window? Because sliding window, you need to solve the memory requirements of this problem, and so I need to know if I need to go over sliding window or not. Basically, right now the memory is way too high. So if there's no response, I'm just gonna assume that I do not need to go over sliding window, and that in that case we're just done. And oh, okay, so I'll go over sliding window, and then I don't think we have time to code it, so I'll just go over sliding window, and uh, and yeah, that'd be it. And next time I'll do the stream on a higher or a lower frequency. Okay. So sliding window, the idea is to find dpijk, we need to know dpi minus 1. We don't need to know dpi minus 2 or dpi minus 3. So we can simply delete it. So we can declare our dp rate, and if you're like, for the code, my code right here does this. So you can just look at that for the code, but I'm not going to write no time. So we can say dp2 k n times 26, right? Declare an array like this. And then we say dp 1 jk equals max of we take I and we don't take I, right? And just loop through all of that. So I'll just write loop I, loop j, loop k, and then okay, you do this, and then here you say swap dp0 and dp. You don't say I minus 1, you say dp0, and then you swap dp0 and dp1. So basically what this represents is dp0 equals dpi minus 1, dp1 equals dpi, and then every time you increase I, move dp1 to dp0 and delete dp0. Okay, I'm gonna open this up for last chance for questions before we end the stream. Also, you can like and subscribe. Could we get the paste bin of? Oh yeah, I guess I'll just put the codes on paste bin now. Let me see if there's any links to sliding window. Here's a Geeks for Geeks on it. I hope it's the same thing. Oh wait. No, it's not. But it seems like... Um... So I don't really find any... so we send email of what? To clarify, I don't really find any sliding window algorithms. But the idea is that instead of saying DP, the idea is that since DPI only comes from DPI minus 1, we don't need to store the whole DP array. We only need to store DPI. And that's the idea behind sliding window. If I do find an email or a link, I will send it out through email. And I don't know what you send email of what. I'm sorry I don't have any links, but yeah. Yeah, for the code. Okay, here's the barn painting spin code. Okay, so I'll add this to the feedback form for this week. The reason I haven't sent it in the past is because I don't want to spam people. But I guess people do want that and they don't consider it spam, then I will definitely